right, welcome to part 2 of 1.1 video. All right, so in that first video, we stopped here at complement and supplement. So now we are going to cover that third part, which is special triangles. All right, so continue taking the triangles. All right, so I think we all know what a triangle is. Okay, so one thing about trig here is when we label the parts of a triangle, like the angles and the sides, we use very specific lettering. Okay, so the angles, A, B, C, the angles, we use uppercase letters. Okay, so angles, we use uppercase letters. And it doesn't matter what letters you use. The important thing is that you use uppercase letters. And then for the sides, we use lowercase letters. And they have to correspond with the angle that it's opposite from. Okay, so let's take a look. So here we have angle A, and then we have these three sides, right? So in relation to angle A is next to these two. But angle A is across or opposite from this side, right? Angle A, it's like angle A touches these two and is opposite from this side. So this side has to be labeled with the lowercase a. It has to, okay? And then the same thing with B and C. B is next to these two sides, so they cannot be B. B is opposite this side, so this side has to be lowercase b. Okay, and then same thing with C. This side over here is opposite from C, so this side is lowercase c. Okay, so sides are lowercase letters opposite to the angle. Okay, and then another thing we need to know, very important here, the sum of the angles. I'm going to use this symbol for angles. So the sum of the angles equals, who remembers? Very good, 180 degrees. Okay. Okay, so we're going to take a look at just some classifications of triangles. So we're going to look at how we classify triangles based on their sides, and then we're going to look at how to classify triangles based on their angles, and then we'll focus on the right angle, the right triangle. Okay. All right, so special triangles. So this here, this classification is based on their sides. Okay, so we have the equilateral. Equilateral triangle. All three sides are congruent. Congruent means that they're equal in measure. Okay, so all sides are congruent. Okay, and there's an implication here. So if the all sides are congruent, then this implies that all angles are congruent. Okay? All right, and then isosceles. The isosceles triangle, that one, not all three sides are congruent, but two of the sides are. Okay? So here, two sides are congruent. If you remember what the symbol is for congruent, you can use that instead of having to spell out the word congruent. Okay, two sides congruent. So just like that. And that implies something as well. If you have two sides congruent, then you have that the two base angles are congruent. Okay? And then we have the scaling. Scaling triangles, none of the sides are congruent. So equilateral, all three sides congruent. Isosceles, two of them are. Scaling, none of them. Okay? So let's see. Let me try to draw one. Okay, so over here, this side is different from this side, which is different from this side. Okay? So here, zero sides, congruent. And this means zero angles are congruent. Okay, so equilateral, all three sides, isosceles, two sides, scaling, no sides congruent. Okay, so these are the classifications of triangles based on their sides. We also have triangle classifications based on their angles. So let's take a look at those. Special triangles. And this will be based on angles. All right, so we have acute, we have obtuse, and we have the right triangle. Okay, acute means all angles are less than 90. All angles less than 90. Okay, obtuse, one of the angles is more than 90. So one angle is more than 90. So we have less than 90, we have more than 90, and then right triangle we have exactly 90. So one angle is 90. Okay? And we're going to be focusing on that right triangle. Okay? But these are just some classifications. Okay, so let's take a look at the right triangle and let's see if you guys remember how to use the Pythagorean theorem. Alright, so right triangle. Okay, so let's see. Let me draw a right triangle here. We usually have the little box here. And if you remember, the hypotenuse is always the side that's across from the 90 degrees. Okay? And let me write that down. Hypotenuse. And then we call these guys legs. Leg 1, leg 2, leg 1, leg 2. It doesn't matter which one is 1 or 2. Okay? And so what happens is if you have this 90 degree, then if you square the legs and add them, that should equal to the hypotenuse squared. So let's go ahead and write that down somehow. Let's see. let me call this one A. And I'll call this B. And I'll call this C. Alright, so if you have a 90 degree, if, here, let's call this angle C. So if C is 90 degrees, then A squared plus B squared equals C squared. That's your Pythagorean theorem. Okay? All right, so let's take a look at an example here. Find the missing side. And suppose that I have this right triangle. Okay, and suppose this is the missing side. So suppose I know that is 7 and this is 2. Then according to my Pythagorean theorem, then I know that x squared plus 2 squared equals 7 squared. So x squared plus 4 equals 49. Solving for x, subtract 4 on both sides. So x squared equals 45. And then we have to take the square root of both sides to get rid of the square. And then we can simplify square root of 45 because I can actually break down 45 using perfect square 9 times 5. And the square root of 9 is actually 3. So square root 45 simplifies to 3 square root of 5. Okay. Let's take a look at another example. One that's a little more abstract. Okay, but same process nonetheless. So suppose that this is x. And suppose that this one is not a nice simple number like the example above, but it is x plus 7. And this is 13. Okay, so we still need to solve for x. Okay, we have a right triangle. We have all 3 sides. So we are going to use Pythagorean theorem. So x squared plus x plus 7 squared equals 13 squared. Okay? So x squared is just x squared. And then over here, x plus 7 squared. All right, so let's go off over here. For those of you guys who don't know what this means, x plus 7 squared means x plus 7 times itself. Okay, so you'll have to multiply that out. Okay, you should be able to know how to do that in your head. So you should get x squared plus 14x plus 49. Okay, now if you're like, I don't understand how you got those 3 terms, let me show you. You distribute this x, you get x squared. And then here you get plus 7x. And then once you're done distributing the x, then you have to distribute the 7. 7 times x is 7x. 7 times 7 is 49. And then here, these 2 terms here in the middle are like terms. So I'm going to go ahead and combine these 2 terms. So I get x squared plus 14x plus 49. Okay? All right. And then 13 squared, 169. Okay. All right, so we need to solve for x. So let me combine these 2 x squares. and then I have this here. Okay, so now I have a quadratic. So when you have a quadratic trinomial, then you want to set it equal to 0. So I'm going to go ahead and subtract 169. And then once you do that, then you can try factoring. Okay. So quadratic, set it equal to 0. Okay. And then you can try factoring or the quadratic formula. I also notice here that, oh, that's divisible by 2, that's divisible by 2, that's divisible by 2. They're all divisible by 2. So I'm going to make my number smaller by dividing both sides by 2. So 2 divided by 2 is 1. 14 divided by 2 is 7. 120 divided by 2 is 60. And 0 divided by 2 is still 0. Okay, and then this makes it a little bit easier to figure out my factoring. I know it'll be positive, negative, and it's going to be 5 and 12. 12 over here, 5 over here, and that will give me the negative 60 and then the positive 7. Alright, so x plus 12 equals 0, or x minus 5 equals 0. Subtract 12. I get x equals negative 12, but that answer does not make sense, right? This negative 12 doesn't make sense. You can't have a side that's negative 12, okay? If I add 5 here, x equals 5. 5 makes sense. So this side is 5, and this side is 5 plus 7, which is 12. Okay? All right. So that's how you use the Pythagorean theorem. Hopefully you know how to factor. Okay, so now we're going to take a look at 2 other special triangles, special right triangles, the 30, 60, 90 triangle, and then the 45, 45, 90 triangle. Okay? So let's take a look at the 30, 60, 90. Okay, so what is the 30, 60, 90 triangle? The 30, 60, 90 triangle is a triangle where you have 60 degrees, 30 degrees, and 90 degrees. Okay? So that's what the 30, 60, 90 triangle is. Okay, so what we're going to do is we're going to take a look at how the sides relate to each other. Okay, so before we look into the 30, 60, let's go ahead and consider 2 of these. So let's consider this triangle also on this side. Okay? So like a mirror image of it. And if I do that, then this would be 90, this would be 60, and this one would be 30, right? Okay? So let's take a look at that. So this is what I have right now, right? And this is 30, and this is 60. Right? And so what I'm doing is I'm going to draw another one over here. And so this is 60, this is 90, and this is 30. Right? So I have 2 30, 60 triangles, right? So what that looks like is this. 60, 60, 60. All of the angles are congruent, okay? And so what happens is, suppose that I let this side be x. Well, we know that this is an equilateral triangle, so this side is also x, and this side is also x, right? Okay, so then now, what I'm going to do is I'm going to go ahead and cut this in half. Okay, so now we're going to bring it back to the single. The single 3060. Okay, well, this side is still x, and this side is now cut in half, so this is x over 2. And this side, I don't know what that is, so I'm going to call it a. Right? Alright, so I have a right triangle, so I'm going to use my Pythagorean theorem. So I'm going to use the fact that a squared plus x over 2 squared equals x squared. Okay, and I get a squared plus x squared over 4 equals x squared. Okay, and I'm trying to solve for a. I'm trying to solve for this one right here. Okay, so I'm going to go ahead and subtract x squared over 4 from both sides. Okay, so I get a squared equals 1 minus a fourth is 3/4. And then I take the square root. Okay, and so here, square root 3 will remain. Okay, but then we have square root of 4 is 2. Square root of x squared is x. Okay, so that's what we have. Let me go ahead and draw the triangle down here so we don't have to scroll up. Alright, so this is the triangle that we have now. Okay, so a is square root 3 over 2x. This is x over 2, and this one is x. Okay, so this is our relationship with the 3060 triangle. That's one way to read it. If you don't like the fractions, we could multiply all of the sides by 2. Okay, and if you multiply all the sides by 2, right, then that leaves me with no fraction there, no fraction here, and no fraction there. Okay, so either one is fine. I believe your book uses this one, so this might be the one you want to memorize. Okay, you can just draw that. When you're doing the homework, just have this drawing handy because it'll ask you to find the missing side. Okay, so one thing about this, let's just go ahead and write down specifics here. We know the hypotenuse, so that if they ask you to find the hypotenuse and they tell you what x is, it's going to be 2 times x. All right, and then over here, okay, this one, I mean, it's not drawn correctly, but this side here is actually the shortest side. The shortest side. The shortest side, which is between, the shortest side is the one that connects like the 60 and the 90. Okay. Okay, so this one is x, and then the other leg, so the long leg, and this is the one that connects the 30 and the 90, is square root 3 times x. Okay? So if you just have these two pieces of information together on like an index card, as you do the homework, you should be fine with finding the missing sides. Okay? So for example, you might have something like this. If the shortest side of a 30, 60, 90 triangle is 5, find the other two sides. Okay. If it makes it easier to draw it, and we know the shortest side is the 60-90 side, so this side is 5. Okay, so we need to find the other two sides. Okay, we know that the hypotenuse is 2x. Okay, so if this is x, then over here 2x is going to be 2 times 5, which is 10. Okay, so the hypotenuse is 10. The other side that's missing, we see it's square root 3 times x. So let me write that down. Square root 3 times x. And if I do square root 3 times x, that's square root 3 times 5. So that gets written like that. Okay, so this is one of the missing sides, and this is the other missing side. Okay. Okay. All right, let's take a look at the 45, 45, 90 triangle. If you get word problems about like a ladder leaning up against the side of a building, draw it out. You're going to get a triangle. You know, this section is about right triangles. It's about 30, 60 triangles, or 45, 45, 90 triangles. So draw it out. They say, oh, a ladder's leaning up against a building. Okay. Then draw that. And they say, okay, well, a light pole has a shadow. Okay, then draw it, you know. So just when you work with word problems, just draw the pictures. Okay. All right, 45, 45, 90 triangle. Okay, so what does that look like? Well, you have this, and you have 45, 45 on the other two. Okay, so that's a 45, 45, 90 degree triangle. Well, we see here that these two are the same, therefore these two must be congruent. Okay, and here, if I call this x, then this one is x, and we don't know the hypotenuse, so we'll call it c. Okay, and if we use Pythagorean here, I see that x squared plus x squared equals c squared, and I get 2x squared equals c squared. And if I try to solve for c, I'll take the square root of 2x squared, and I see that I am left with square root 2 times x. Okay, so here the hypotenuse is square root 2 times x. Okay, so here you just need this diagram here in order to do the problems where they say, oh, go ahead and find the missing sides for the 45, 45, 90 degree triangle. Okay, so let's take a look at an example. All right, find the lengths of the legs if a 45, 45, 90 degree triangle has hypotenuse equal to 10. Okay? All right, so let's draw this. We know this is 45, 45. And then we know the hypotenuse is 10. And we know these two are the same. You could use, I guess, you could use Pythagorean, I guess. But it's pretty easy just to use the information here. We know that c is square root 2 times x. So that's your equation. 10 equals square root 2 times x, solve for x. Divide both sides by square root 2. And you get 10 over square root 2 equals x. Okay? Rationalize the denominator. So you have to multiply. Here, let me get a different color. Multiply by 1 in the form of square root 2 over 2. And that will give you 10 square root 2 on the top and square root 4 on the bottom. But what is square root 4? It's 2. Okay? So that's what we mean by rationalizing the denominator. Okay? All right. And then if you punch that into your calculator, you will get 7.1 feet. Okay? And which answer will they want on WebAssign? Not sure. Play around with it. Just be good at simplifying. So like rationalize your denominator. You could still simplify there. So maybe they will take this. Maybe they will take this one. Okay? All right. If you have any questions, make sure you email me or text message me.